As the climate changes, we hear many stories of places that have relatively stable weather conditions beginning to experience extreme weather conditions that have major implications on society. Haiti, in 2016, was severely hit by Hurricane Nicole, leading to food insecurity and disease outbreaks, which affected over 1 million people. Zimbabwe witnessed extreme drought in 2017 due to no rainwater and heat stress, leading to loss of agricultural production. In the United States, the hot days are getting hotter and becoming more frequent, while cold days are becoming fewer. Climate researchers in the Center for Climate and Energy Solutions have projected changes in the number of days in the year that would experience maximum temperatures of 120 degrees Fahrenheit, and over 50% of the states in the United States would experience heat waves of above 90 degrees Fahrenheit. So why is all of this important? Climate change poses a huge threat to human existence, and global reliance on unsustainable energy and resources is contributing to the problem. Changes in temperature over time lead to disruptions in the balance of nature. We see hotter weather conditions leading to extreme wildfires, loss of land biomass and property, severe storms destroying homes, communities, and economies, decreased air quality, trans-border disruptions, wars, and so many more. So life as we know it might get disrupted if we decide to ignore the consequences of our human actions on the use of Earth's resources.
Some researchers believe that we can slow down the rate and effects of climate change using a technology called solar geoengineering. In this video, we will learn what solar geoengineering is, why people want to use it, and why it's so controversial. While humans have been manipulating the environment for thousands of years, the term geoengineering is used to describe the application of technologies with the intent to make large-scale changes to the environment. Under this definition, some of the earliest descriptions of what we know as geoengineering come from American meteorologist James Pollard Espy in 1841. Espy argued that his heated columns of air would create rain on command. Most people did not take his proposals very seriously at the time. Around the era of World War II, governments became increasingly interested in the possibility of manipulating weather patterns. Both the United States and the Soviet Union began initiatives to study geoengineering technologies and possible wartime applications. One of the first instances of weaponized weather manipulation was by the United States in Vietnam. Called Operation Popeye, this operation used the Air Force to disperse chemicals in the air in order to lengthen the monsoon season and inhibit the movement of northern Vietnamese fighters. After Operation Popeye, the United Nations passed the Environmental Modification Convention to prevent any future uses of climate alterations during conflict. In the following decades, as the scientific consensus around climate change grew, discussions about manipulating the climate at a large scale once again emerged. We will now learn about the two most commonly discussed solar geoengineering technology.
Think about the ways you block out the effects of the sun, either from hurting your eyes or making you hotter than normal. That is the idea behind solar geoengineering, except on a large scale. Solar geoengineering, also called solar radiation management, simply refers to the process of cooling the Earth's temperature by reflecting sunlight back into space. It is a proposed climate change adaptation technology, and the goal is to alter the atmospheric concentrations of emitted greenhouse gases that deplete the stratospheric layers and to slow down the effects of climate change. The two commonly identified solar geoengineering technological methods include the stratospheric aerosol injection and the marine cloud brightening. The stratospheric aerosol injection method, SAI, infuses tiny reflective aerosols into the stratosphere, while the marine cloud brightening, MCB, aims to modify the surface proportion of certain clouds to increase their sunlight reflectivity back to space. The processes involved in the use of solar geoengineering technologies are shaped by the commitment of numerous governance actors and stakeholders who regulate and enforce climate moderations that are consistent with reducing greenhouse gases. Because of its regional and global effects of unprecedented climate patterns, the central actors of solar geoengineering include states and intergovernmental agencies who are concerned with aggregate decision-making, enforcement, and arbitration. This includes the United Nations, Country of Parties, Intergovernmental Panel on Climate Change, university researchers, scientists, private nonprofits like Bill and Melinda Gates Foundation, non-state actors like national academies, and environmental advocacy unions like the Union of Concerned Scientists. These actors or stakeholders interact with one another to collaborate, influence policies and research, while also holding each other accountable when questionable or unattainable measures are being adopted.
You might have seen movies about climate control gone wrong, like Snowpiercer or Geostorm. While most scientists agree that consequences on that scale due to solar geoengineering are unlikely, the technologies and concept remain controversial. One concern about solar geoengineering is that since we may be able to mitigate some of the worst effects of climate change with solar geoengineering, some industries and governments could take that as an opportunity to increase carbon emissions rather than decrease. Additionally, solar geoengineering is difficult to implement and control on a small scale, making it impossible to fully plan for and identify all potential risks of implementation. On the other side of the debate, proponents argue that solar geoengineering should be a critical component of our global climate change strategy, giving humanity more time to implement technology like carbon capture and renewable energy systems, and, according to some research, could reduce the impact of natural disasters like cyclones. Climate change is a complex problem, and no one technology is going to solve it all. Solar geoengineering could be one part of our global approach to sustainable development and climate action, but it's not without risks and consequences. Whether or not those risks are worth taking is a question we should all be asking.